Long before the first clock ever ticked, humans still had to answer some very practical questions. When should we plant? When will the herds migrate? How long until the river floods again? Time wasn't an abstract idea to our ancestors, it was a survival tool. And it turns out, nature had already built a remarkably accurate clock, calendar, and alarm system, if you knew how to read it. So how exactly did people living tens of thousands of years ago track time without a single gear, battery, or digital display? The answer lies in careful, patient observation of the sky, the land, and the rhythms of life around them. The most obvious clock available to early humans was the sun itself. Its rising and setting marked the most basic unit of time, the day. But early humans got more sophisticated than just noticing light and dark. By watching the changing angle and length of shadows cast by trees, rock formations, or deliberately placed sticks, communities could estimate the time of day with surprising precision. Some archaeological sites suggest people used natural landmarks, a distinctive peak, a gap between hills, to note exactly where the sun rose or set on a given day. This wasn't casual guesswork, it required generations of accumulated knowledge, passed down carefully because getting it wrong could mean missing a hunting window or a critical seasonal move. While the sun handled the day, the moon offered something even more useful, a way to count longer stretches of time. The moon's cycle of roughly 29.5 days, from full to full again, is remarkably consistent, which made it one of the earliest natural calendars. Some of the oldest known artifacts hint at this. Notched bones and antlers, dating back tens of thousands of years, show patterns of marks that many researchers believe track lunar phases. Whether used to predict animal behavior, plan gatherings, or anticipate migrations, the moon gave ancient people a reliable way to organize weeks and months long before anyone wrote a word. Beyond the moon, the stars themselves became a slower, grander calendar. Certain constellations only appear on the horizon at specific times of the year, and ancient peoples across the world noticed this. The heliacal rising of a particular star cluster might signal that the rains were coming, or that it was time to move camp before winter set in. This kind of star tracking required serious dedication, essentially informal astronomers within the community, often elders, who watched the sky night after night and remembered patterns across many years. Their observations weren't superstition. They were data, collected the hard way, and passed on as essential survival knowledge to the next generation. Of course, the most dramatic natural calendar of all was the changing of the seasons. Early humans didn't need instruments to notice when leaves changed color, when certain berries ripened, or when rivers swelled with snowmelt. These seasonal markers were tied directly to survival strategies. Knowing that salmon would run upstream at a certain point, or that specific plants would flower right before animals gave birth, allowed communities to prepare in advance, gathering tools, relocating camps, or stockpiling food. This is why so much ancient knowledge was organized not around abstract months, but around events, the time when the berries ripen or the season the herds return. Time was measured by what was happening in the world, not by a number on a wall. Animal behavior itself became another dependable clock. Birds migrating in massive flocks signaled seasonal shifts long before temperatures changed. The mating calls of certain species, the shedding patterns of others, even insect activity, all offered early humans clues about where they stood in the yearly cycle. Some evidence suggests that hunting parties timed their movements around these exact behavioral cues, following herds not randomly, but based on a working mental calendar built from years of pattern recognition. This kind of knowledge required no writing system at all. It lived in oral tradition, in stories, and in direct apprenticeship, as older generations taught younger ones how to read these living signs. Eventually, humans began to externalize this knowledge, carving it into something more permanent. Notched bones, tally marks on cave walls, and eventually structures aligned with solstices, like early stone monuments, show a clear progression toward formalized timekeeping. These weren't just artistic flourishes. Many archaeologists interpret them as some of humanity's first true calendars, tools designed specifically to track recurring cycles. This shift from purely observational knowledge to physical record-keeping marks an important turning point. It meant time could be communicated, verified, and refined across generations, rather than relying solely on memory. So while ancient humans never had a clock ticking on the wall, they were far from lost in time. They built intricate, functional systems using the sun, moon, stars, seasons, and even animal behavior, systems accurate enough to guide hunting, farming, migration, and survival across thousands of years. In many ways, they were paying closer attention to the natural world than most of us do today. The next time you check your phone for the date, it's worth remembering, long before numbers and calendars, humans were already expert timekeepers. They just used the whole sky and the whole earth as their instrument.